Good morning. This lesson is for my Integrated 1 class, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this, but I'm going to title it how I title in the title. But what I am sure of is our one goal. And our first and only goal is to solve two-step inequalities and graphing their solutions. Let's go ahead and do some review here. So remember that the variable is a shading. This symbol and this symbol we consider left of. This symbol and this symbol we consider right of. This symbol and this symbol, the circle is open, which means it's not part of the solution. And this symbol and this symbol, the circle is closed, which means that the circle is part of the solution. All right, so let me just remind you what we are doing. I was asked by a student many years ago, how do you know what to do first? How do you know what to do next? So I came up with 6 steps to solve. I added a 7th because it's the inequalities we have to graph. But the student asked me a very good question. How do you know what to do first? How do you know what to do next? So I came up with the 6 steps to solve. I have to alter it a little bit to make it fit inequalities, but let me just go through the steps. Step 1 is going to be to eliminate fractions by multiplying everyone by the denominator. Step 2 is going to be to distribute. We have parentheses. Step 3 is to combine like terms on each side of the inequality symbol. Step 4 is to get all variables to one side of the inequality symbol using addition or subtraction. Step 5, we're going to add or subtract away a number from the variable side of the inequality symbol. That means that if I have a plus or a minus between the number and the variable, I do step 5. Step 6, divide away a number from the variable side of the inequality symbol. Nothing between the number and the variable. And step 7, graph. So if we follow these steps, we should be able to solve any inequality. And if we change inequality symbols for equal signs, any equation. So let's just jump right in, solve and graph these. And then hopefully it makes sense on how I use it. So again, these are only going to be 2 steps, so I can only use 2 of these to solve this. All right, so the first problem. 1, 2, 3, 4, 5, 6, 7. I'm writing these numbers so it reinforces that I follow these steps. Step 1, do I have a fraction? No, I can't eliminate a fraction, so I can't do step 1. Step 2, do I have parentheses? No, I do not, so I can't distribute. Step 3, can I combine like terms on each side of the inequality symbol? I can't put these together, and there's no one to put together with that 5, so I can't do that. Step 4, can I get all variables to one side of the inequality symbol using addition or subtraction? No, I do not need to do that because the x is already on the left side. Step 5, can I add or subtract away a number from the variable side of the inequality symbol, meaning that I have a plus or a minus between the number and the variable. Yes, I have a number that has a minus sign between it and the variable. So I need to do step 5 with this minus 3. So since I have a minus 3, I must add 3 to both sides. Those are going to cancel. Now I have 2x is right of or greater than 8. Step 6, divide away a number from the variable side of the inequality symbol. That means there's nothing between a number and a variable. Close that parenthesis. I have a 2 that's right next to the x, and there's nothing between it, so I need to do step 6. Divide by 2, divide by 2. All right, so let's see here. The 2's cancel out, and I'm left with x is greater than or right of 4. All right, so let's go ahead and graph this. And again, we're going to interpret this, and the variable is the shading. So what this translates to is the shading is right of 4. The shading is right of 4. You don't have to write this out. I'm just reinforcing how I interpret inequalities. The shading is right of 4. So what I'm going to do is I'm going to put a circle that's open because that's what this symbol tells me to do. Okay, I'm just going to translate it. The shading is right of 4. So I'm going to shade on the right side of 4. Okay. So that's me using the 2 steps to solve and my graphing step. All right. So let's move on to the second problem. 1, 2, 3, 4, 5, 6, 7. All right, and again, I'm just going to go through and use the steps. If I have it, I use it. If I don't, I move on. Step 1, can I eliminate a fraction by multiplying everyone by the denominator? I have a fraction, so I can eliminate that fraction by multiplying everybody by the denominator. So what I'm going to do is I'm going to multiply this by a 3. I'm doing step 1. This by a 3, and this by 3. This is me multiplying everybody by the denominator. So that cancels out. I'm now left with 6 is left or right over greater than or equal to 12 plus those cancel out, and now I'm just left with my x. Okay, so that's how I do step 1. Eliminate fractions by multiplying everyone by the denominator. Okay, step 2. Do I have parentheses? No, I do not, so I cannot distribute. Step 3. Can I combine like terms on each side of the inequality symbol? Nothing to combine. I can't put these together. They're not like terms. Step 4. Get all variables to one side of the inequality symbol using addition or subtraction. Well, all the variables are on the right side, so I can't do step 4. Step 5. Can I add or subtract away a number from the variable side of the inequality symbol? Yes, I can, because I have a plus or a minus between a number and a variable. There's a plus between the number and the variable, so I can do step 5. This is a positive 12, so I can get rid of it by subtracting it to both sides. So that's going to cancel out. If I have 6, I owe 12. That means that I owe you 6. Negative 6 is right of or at the shading. All right, so let's translate that. Negative 6 is right of or at the shading, right? So go ahead and draw your graph, put a negative 6. We close that circle because that's the add, it's part of the solution, right? So it's closed. Let's interpret this. Negative 6 is on the right of the shading. So if it's on the right of the shading, that means that I have to shade to the left, because negative 6 is on the right side of the shading. All right, so I did step, I didn't need to do that, and I did the graph. So again, this was a 2-step problem. Now, as I look at this, I realize I left something out right here. Divide away a number from the variable side of the inequality symbol. Nothing, and you do this if there's nothing between the number and the variable. And if we divide by negative, switch the inequality symbol. I forgot to put that in. I don't have the time to record this and write all this, so this is going to have to do. All right. So if we divide by a negative, we must switch the inequality symbol. Okay. So we've done one problem, we've done 2 problems. They've each been 2-step problems. I've used my list, and again, let's continue with this, and hopefully this is making some sense to you and answering the question: how do I know what to do first? How do I know what to do next? Okay. Step 1. Do I have a fraction that I can eliminate by multiplying everyone by the denominator? And yes, I can. I can eliminate this 2 by multiplying everybody by the denominator. Now, this is considered one number, so this only gets 1, 2. So I'm going to eliminate the fractions by multiplying everyone by the denominator. You cancel out. Minus 3x is left of 12. Can I distribute, meaning I have parentheses? No, I cannot. Can I combine like terms on each side of the inequality symbol? No, I cannot, because each side only has one term. Can I get all my x's to one side? No, I cannot, because all my x's are on one side. I was going to walk over there and point at 4. Can I add or subtract away a number from the variable side of the inequality symbol? No, I cannot, because there's not a plus or a minus between the number and the variable. There's nothing between them, so I can't do step 5. Step 6. I can divide away a number from the variable side of the inequality symbol, because there's nothing between the number and the variable. There's nothing between them. And I'm going to be dividing by a negative, so I need to switch the inequality symbol. I need to do this part, which I forgot to write. Make sure that you're dividing by a negative 3. Those cancel out. X is now to the right of, it used to be to the left. It switches because we're dividing by a negative, and so x is greater than negative 4, or the shading is right of negative 4. All right, so again, let's go to negative 4. Let's start off with a number. It's an open circle because that's what that symbol tells us. It's not part of the solution. And we're going to shade on the right. And remember, the shading are represents all the numbers that if I was to plug into my inequalities, that would give me a true statement. All right, I want to work out two more problems, two more two-step problems. So let me clean this up, and I'll be back. I'm back. So let's go ahead and continue with our goal of solving two-step inequalities and graphing the solution. Remember, I'm using my 6 steps to solve plus my 7th step, which is graphing. All right, so I have 2 more problems to work out, and these are the last type of two-step problems that we can have. Okie dokie. Again, I'm going to write 1 through 7, so it reinforces the idea of going through the steps and answering the question, how do I know what to do first? How do I know what to do next? All right, so for this problem, I'm just going to go through. Can I eliminate fractions by multiplying everyone by the denominator? No, I cannot, because I do not have fractions. Step 2, can I distribute? No, I cannot, because I do not have parentheses. Step 3, can I combine like terms on each side of the inequality symbol? Yes, I can, because 4x and 6x are like terms. You don't change the signs, you put them together as they are, and we get 10x is greater than 30. Okay. Step 4, can I get all my variables to one side of the inequality symbol using addition or subtraction? No, I cannot. They're all on the left. Can't do step 4. Step 5, can I add or subtract away a number from the variable side of the inequality symbol, meaning that I have a plus or minus between my 10 and my x. I have nothing between them. So I can't do step 5, but because I have nothing between them, I must do step 6, and I'm going to divide both sides by 10. So now the 10s cancel out, and I'm left with x is right over at 3. The shading is right over at 3. All right, so I'm going to go to make a point at 3. It has to be closed, which means I shade it in because it's part of the solution, and I shade to the right. Now, I want to mention I didn't have to change this because I didn't divide by a negative, so I didn't have to switch that. All right, so this problem, I showed you how to combine like terms. Okay, it's not by accident. The next problem has the same numbers, but it's set up slightly different. All right, so again, I'm going to write 1 through 7 to reinforce that I'm going to go through these steps to solve my inequality. All right, and here we go. Step 1, can I eliminate fractions by multiplying everyone by the denominator? No, I cannot. I have no fractions. Step 2, I cannot distribute because I do not have parentheses. Step 3, can I combine like terms on each side of the inequality symbol? There's nothing for me to combine with this 4x, and I cannot combine 6x and 30. They are not like terms. So I cannot do step 3. Step 4, can I get all variables to one side of the inequality symbol using addition or subtraction? Yes, I can. Now, some of you might want to subtract the 4x to the 6x, but now we're bringing numbers to the number side of the inequality. We want to get the x's away. So we're going to do step 4, and the way that I get the 6x to the other side is I have to do its opposite. So I'm going to say minus 6x minus 6x. That allows me to cancel it out on the right side of the inequality and move its opposite to the other side. If I have 4 and I owe 6, that means that I owe 2. So 2x is greater than or equal to or right of 30. All right, step 5, can I add or subtract away a number from the variable side of the inequality? Do I have a plus or minus between the negative 2 and the x? No, I do not, so I cannot do step 5. Since there's nothing between them, I must do step 6. So I can't do step 5, I must do step 6, and I am going to divide by a negative, so I have to switch the inequality symbol. So divide by negative 2, divide by negative 2, we're going to get x, and this switches now, is to the left of negative 15. Now, let me write that out. The shading is left of or at negative 15. So I'm going to put a negative 15, fill in my circle because that's what it says to do in that table over there, and I shade to the left. And if I was to plug in any of the values in the shaded area into my inequality, I will get a true statement. And remember, we switch because when you change the signs of numbers, you change their position, and I hope this doesn't offend any of my viewers in the UK, but when you switch the sign of numbers, you change their position, and when you change the position of something, you have to change how you describe their position. All right, so I'm going to go ahead and end this here. I did step 7, and I did step 7. I hope that this helps you solve two-step inequalities. Yeah, and I think I got it also. Again, I hope everyone's having a good day out there. Have a good day, everybody. Bye-bye. I keep doing this wrong. All right, bye-bye.